right here is our ClearView Insight mobile detection platform. It is a self-powered unit that houses a variety of sensors. You can see it is solar powered with a backup generator. So what that does is once the batteries get to a certain level, the generator will automatically come on and it pulses the batteries back up to full charge and then it stops. You can see our tower is 23 feet tall. It's made of polymer. It's got a hollow center so it holds all the electronics and the cabling to keep it protected. At the top we have our camera, a radar system, and a RF jamming device, in addition to passive RF detection. The system has a hydraulic mast, which allows it to go up and go flat so that you can deploy your sensors, put the sensors on at a low level, and then raise it up through the hydraulic system so it can be deployed by one person, usually within about 30 minutes. We're going to go through our sensor suite now, so I will turn it over to Jeff Blair. Jeff is the CEO of Hawkeye. Hawkeye does the C2, where it feeds all variety of the sensors into one user interface.
From Hawkeye, you can control all of the systems on the Insight mobile platform, which means we can track targets, slew cameras, initiate jamming, trigger alerts, all from a common operating platform. The bonus feature of Hawkeye is that we can embed our system inside another system. So in this case, you're actually watching Hawkeye live inside of the Milestone video management platform, the XProtect system. We also have the capability of running as a standalone system, which we'll show here shortly. So ultimate flexibility depending on your environment and your control requirements. With that, what we'd like to do is show a demonstration of our radar technology at approximately 2.2 kilometers. We'll pick up a vehicle around 3.5 kilometers, and then we'll pick up drones at approximately 900 meters for like a Phantom 4 style DJI drone. So you'll notice that here in our video, we've got a vehicle approaching. It's out 400 meters or so. You can see the camera immediately slewed the queue based on criteria on the vehicle, including speed and size. We classify that vehicle as a car, hence the icon here. So the vehicle is going to stop, and we'll have a ground walker jump out. And now we're able to be in position when motion occurs again. Here's our ground walker coming towards us. And then he is going to wave at the camera and then turn back around. We keep our video pretty wide screen so you can get not just the walker, but also the area around them to see how other forces may come into play. Because he exited from a standard target, we kept him as a vehicle classification, and now the vehicle is driving away. We're going to move to the secondary test, which will be on an actual drone. We believe in a layered defense, so we'll be discussing passive radio frequency detection here momentarily. But with a layered defense, the passive RF will detect significant distances, but then when you're close in, within that kilometer or shorter, we're able to use the radar to look for drones as well. The other idea we have is that you will use one camera specifically tuned in for ground targets, and then a second camera will allow us to tune in for like air targets or other targets like that. So we are waiting now to see a drone in the air. And the drone we're using is a challenging drone. It is a DJI Mavic Air, which means it's approximately 6 inches by 4 inches by 2 inches. It is a very small device, flying very quickly, but you'll see that the radar is able to grab it as it approaches the radar. So here we are. You'll see that we've got the drone now located here, target 848. So as the drone comes in, we pick it up. Actually, at 500 meters, we're able to detect a drone that size. Again, it's significantly smaller than a Phantom, and now it's turning around and exiting the area. Which leads us to our next technology we'd like to showcase, and that is radio frequency detection. What we're doing is actually looking for radios. Most systems are actually looking for drones themselves. We are looking for the radio signal between the drone and the pilot or other systems. We are not limited. We have ultimate flexibility in looking across the spectrum to find radios that are being used in the area, which means that we can track not only drones at various frequencies across the spectrum, we also have the capability to look for ground walkers with two-way radios or other technologies. I left up the waterfall display here to show that we are actively looking for frequencies. We have multiple drones launching. As they get into the air, you'll see them appear as red dots. in this situation, we've got a drone hovering here in the back, and then we will have another drone's actually taking off in this area. You'll see him curve around. We'll actually do a 10-second jam, and we'll show you what that looks like in the waterfall display. When the jamming occurs for 10 seconds, it'll break the connection to the drone on multiple frequencies, the 2.4 and 5.8 gigahertz frequencies, which means the drone will get lost and confused as to where it is. It will then return home, return to sender. We're going to ask our technician to initiate jamming here, and then you'll see the drones immediately drop off, and then the radios will reacquire, and here we are jamming. So you can see the sharp spikes, and this just shows that it is sending out energy across a variety of frequency sets. You'll notice that up here on the map, we've lost the red target dots. The drones have gone offline. Because it's on for 10 seconds, they've lost both of their 2.4 and 5.8 gigahertz signals. Then as the drones begin broadcasting again, because they've stopped jamming, see them begin to return from whence they came. But once those drones go into that confused mode, it is a standard operating procedure for them to be returned back to sender. Where it is legally allowed, we can also jam GPS. And when we jam GPS, the drones will actually land themselves. So that'll give you an opportunity to collect the drones for forensic data and further analysis. With that description of our radar and jamming, as well as passive RF detection systems, I'd like to return the presentation back to Jason.
All right, thanks, Jeff, and thank you for watching the demo. I look forward to answering any questions.